Hi everyone, welcome to another video, and today we're going to discuss about a new data structure called tries. Tries is one of the important data structure mainly used to process words. For example, we are processing a word called apple and another word called app. So you can see that the app is already present in apple, so that we can leverage the spaces that we created for app, that is common in both the word, and we don't have to create extra space for that, and that's where the try data structure comes in. So let me explain the same on whiteboard. So now then, assume that we have a word 1 as apple, right, and word 2 as app, right. Now see how we're going to process apple. For example, tries can be created using array, but we're going to create using map, because map will be the most efficient one. So we're going to create first the time we're going to process a word. You're going to take the word and we're going to create a map, right? And we'll see if the map has the character A. No, then we're going to create the character. Then A will be pointing to the next character, that is P. Then P will be pointing to the next, that is P. Then L, and the last character will be E. And here in this map, okay, so every node here, the nodes, these are the nodes. This will be a map by themselves. At the end of the word, right, the end character of the word, we can mark it like end of the word, or end equal to true. Now when we process app, we're gonna take A. We're gonna see A already exists, so we don't have to create any space. We're gonna just skip it. Then P, okay, A to P already exists, so we don't have to create one. Then let's go to the next character. Again, a P exists, so we don't have to create one, and we just can mark it end here, so that when we check for APP, right, when we check for if APP is present, we find the end of that word and we can return yes, the APP is present in our word collection, or we can call it a dictionary, right? Now think about another word 3, that we want to insert, maybe A, P, P, APP, maybe APPE, okay, appe or something like that. So what's going to happen now when we process the appe word? What it's going to do now? So this is one end and this is one end. Now it's going to check again our dictionary. A is present, so it's not going to create anything. It's going to go to next node. P exists, then next node P exists, then it find E is not exist here, so it's going to create E here with end, with a end pointer or end property. So next time when we check if APP is present, it's going to check this stream to E, and we find end, and going to return true. So you see now how effectively it's saving various words with less memory, right? So anytime we need to process some words, create a dictionary and check word present or prefix present, those kind of stuff, we can efficiently use this data structure. Now then, let's implement the try using JavaScript, and we're going to use maps. We are not going to use array. If you see the normal way, people are going to create array of 26 characters, and for every character there will be children array. So we're not going to create that. We're going to create it using maps, because maps are the most efficient one to create tries. So if you see my screen, I have a class try. So we're going to create a node as well. so that we can use it when needed. So const node equals to, it's gonna return us a new node that is nothing but a map, new map, and by default our end of word will be false. Right now, when we go to tries, we're going to create our constructor, and it will create this dot try equals to new, sorry, just node. So it's going to initiate our try with a blank node. Then we're going to create a method that is add, and it will take a word. So now what's going to happen, we have to go character by character in the word, and we're going to check if it's present in our tries. If so, then we have to move our pointer to the next. So let's create our node, like let node equals to this dot try, right? Then we're going to create our for loop for let I equals to 0, then I less than our word dot length, then we're gonna I plus plus. What? And then we're gonna create our let c, that is character, equals to word of I. We're going to give our character. Then we're going to check if our node has the character property or not. If not, we're going to insert it, right? If not, if present, we just have to pass it. So if like if node dot has c, don't have c, then we have to insert it, right? So node dot set, we're gonna set c, then it will set with a new node. Else, whether we created a new node or we already found a node that already exists, we just have to go to the next pointer. So our node will become node.get c. So it will return us the next map. Now we have to check for the end of the word. So if I equals to words dot word dot length minus 1, then we have to just set, node set our end property to true. So when we search for that word, we're gonna check for this property, and we find when we find true, it means that word exists. So that's all about add. Now we have to write a new method that will check for the word, right? You're gonna check, it's gonna take a word as argument, and it's gonna do the same logic, by the way, nothing new, and it will check if the word exists or not. It will return us. So let node equals to this dot try, and then same, it's gonna write the for loop, and I, then it's gonna go for, we have to fix it, word dot length, then let's see. Okay, then C is our character. Then we're gonna do the same. If node, if we don't find the character in the node, it means it doesn't exist. So we're gonna check that. If node as C not present, then we're gonna return false. If not, we're gonna do the same. We're gonna skip node equals to node.get C, right? And then if we find end of this word, we're gonna check if the if the end of the word present, then we're gonna return true. So if I equals to word dot length -1, if okay, return node.get end, right? If the word doesn't present anyway, it's gonna return the false. If present, it's gonna return true. So that's all about our try implementation. Now let's see the test cases. So I have created a test case that will add a worker apple. Then when we find the apple, it's gonna return us true. Then we're gonna find app gonna return false, because what happened here, app is present in apple, but when we reach the end of app, our end property will be still false for app, because we did not inserted app, so it's gonna return false. Then we're gonna add app. For this particular case, the end property of this second P will become true. And so when we try to get, again check if app is present in our dictionary or in our try, it's gonna return true. Now let's run our test cases. What happened? Oops. It's gonna be word. Perfect. So that's all about tries. And tries are very important, by the way, because there are many problems that can be solved using try. Mainly if it asks for word prefix kind of problems, or word searching of words, those kind of stuffs, we definitely can use tries. So thank you for watching.